This is a non-technical overview of the Mike Basin model. More detailed and technical presentations can be accessed on the DHI website. Water is vital for economic growth and development. Threats include too much water, flooding, too little water, droughts, water that is too dirty, and water that is too expensive. Questions that often need answering include questions around water security. For example, is a catchment currently over-allocated or under-allocated? When will full allocation take place? What impact will climate change have on water security? What will the impact of new dams be, or water treatment plants? What is the potential of hydropower in a catchment? Where is it? And what can be done to optimize existing hydropower? Irrigation is normally the largest water user internationally. Questions may abound around how irrigators can do better with less water. Mike Basin is a modeling framework that represents both the sources of water as well as the users of water. The sources of water include rivers, dams, and groundwater, so both surface water and groundwater is included. From the water user's point of view, it can consider domestic and industrial use, irrigation, environmental flow requirements, etc. The unique feature of the model is that it's able to represent the water apportionment rules that exist, dictating who gets what and when. And from that, a reconciliation can be done between supply and demand, and the water security or assurances of water supply can be worked out for the various water users for the given operating rules and apportionment rules that exist. Let's take a look at how some of our clients have benefited from the use of Mike Basin. After introducing a new water framework in the EU, Greece recognized that it required an improved water management decision support system. This system needed to consider both groundwater, surface water, economics, and this needed to be done in a GIS and environment. They used Mike Basin with Mike She, which was then linked with an economic model. The benefit was improved decision making. The Niger River consists of 9 different countries in that basin. There was a need to improve water security decision making. Mike Basin was used to analyze current and future water use options. The countries can use the model individually or jointly, and they use this to assess how best to use the water. Another example is in Peru, where Mike Basin has been used to optimize hydropower. This is done in combination with a package called Mike FloodWatch, which allows information to come into Mike Basin on a real-time or near real-time basis. Increases in hydropower were obtained via the use of this combination. Let's now consider some developments that are taking place in DHI. DHI is busy developing a Nile Basin decision support system. We believe this is a new era for water resource management, as we are putting together a very comprehensive decision support system. The system consists of many different components, of which models will be one, and the Mike Basin model is one of those. What's illustrated here are the different components which relate to the core or information management system, the modeling, and then the real-time access to information. From here you can see that Mike Basin literally plugs into this Nile Basin decision support system, offering the modeler great functionality. Let's consider some of the key features of Mike Basin. Firstly, it is embedded in GIS. This helps with stakeholder participation, as well as helping to set up the model quickly and efficiently. The model has hydropower potential, both considering hydropower potential as well as optimization when linked with a package like CloudWatch. The model can operate at various time steps. So for example, you can run the model on an annual time step, a monthly time step, weekly, daily, or whatever you choose. There is an irrigation model inside Basin, and that can allow irrigators to assess how to do better with less. There's an add-on water quality module, which is also very important for water planning. The model itself can be accessed via the COM interface, so that specialized routines can be added to Basin via this interface. The model is very user-friendly. One of the key features is that it can easily obtain information or send information to and receive it from Excel. And then coming soon is this world-class decision support system platform. In summary, Basin can be used to evaluate water security from both a quantity and quality point of view. Irrigators can use the model to assess how to do better with less water. They can also be used to optimize hydropower and to evaluate the potential thereof, and much more. Thank you, and goodbye.